Hello. Hello.
Hi, hi there.
Hi, can you hear me?
Yeah, can you hear me?
Yeah, I can. Great. Well, let's get started. We have an
Okay.
hour for our coding session, is that correct?
Yeah, I think so.
Great. So I've got a couple of questions prepared. So let's get started. When you finish, we can just keep going. So let's start with the first question. Can you pick the language that you will be using for this problem?
Sure.
That would be Ruby here. Okay.
Yep.
Okay. I don't know how to do block comments for Ruby. I don't know if it's like this. Looks like it's
Oh,
not.
it's an octathorpe. It's a hash.
Oh, so okay,
Pound sign. Yeah. And then I think because this is CoderPad, you can just
yeah.
highlight all of that and then do command
Got it.
front. Yeah. Yep. There you go.
There we go. Yeah. So here's the first question.
Okay. So if we want the first thing that, because it's a tree, um, the first thing that I'll just for my thought process is let's just instantiate class and then um, that'll be nil, and this will be also nil. I can just do an attr accessor here, value left, right. Okay, so to start, this looks like a typical depth first search problem. So in order to do that, I mean, we could do, I think that we're just, if you're going to want to just do a find depth, you're going to want to do a find depth method.
Okay.
And then that's just going to take the whatever the root is. But let me draw this out real quick so I know what exactly I'm doing. So if I have my root node, and that's 3, so 3 is root, and then I am going to look down for. Can you see me highlighting?
Yep. Yep.
Okay, great. So if I see 3 and then I go down to 9, I want to keep track of each of these paths, I think. So if it's a 3 and a 9, then I would have an array, and that's, the length is going to be 2. But I don't really care about what these values are, so I just need to, the sum length is going to be 2. And then here it would be 3, and then 20, and then 15. And that sum length is 3. And then I don't need to care about that anymore because I only care about the minimal sum length. And then if I check 3, 20, and 7, that's also going to be the same thing. So if I'm trying to find the depth, the first thing that I want to do is, I could just check right now if my root value if my root value is equal to yeah, if my I'm trying to think of how to do this if I need to actually know about my root value being nil. I mean, if that's nil, then that's obviously it's not that. But if my root dot right equals nil and my root dot left equals nil, that's going to return false, maybe. Let me just not think about that base case right now.
Okay.
There's a recursive solution that I can do here. I know that. And I know that's going to be like trying to figure out what the sum length is. So if I have 3 as the root, and then 9, and then I just need to figure out if there is a root dot left value. So basically, I start with my length is 0. And then I want to do the find depth, and then I want to do something like root, pass in root dot right, and then I think I need to do, it's not a sum, it's the length is going to be I'm going to pass in the length, I know that, and then I also need to, I think it's also find depth root dot left, and then the length there as well. Let's start with default. Then I think I want to just do a length plus equal 1. But I need, if I'm trying to find my minimum root, I need to also pass in some kind of list value, right?
What does that mean by a minimum root?
The minimal sum? Sorry, the minimal
the minimum
length.
depth. Okay.
Yeah, what does it mean by the minimum depth? It just means that when I'm traversing through my tree, it's going to be whatever is the lowest amount of the lowest length value.
Right, the shortest path to a leaf. Right, that's what we're talking about.
Right. Okay, so if I'm just trying to find the shortest path, well, find depth. It's the shortest path. Yeah. So it's the shortest path. Do I? Yeah. So if it's the shortest path, it is technically a sum, right? So maybe it's
Okay.
yeah. So I don't, well, the sum is always going to be, I think it's going to be something like sum equals sum minus, well, it's not going to be length. And then I'm going to have this root dot right is going to be, and I don't even know if I need to pass in the root dot right value. I need to do root dot right dot value minus, oh, right. So it's going to be something like root dot right minus value minus sum, root dot left dot value minus sum. And then my root, I don't even know if I need to necessarily look at that. I just need to see if the root dot value is equal to nil. And I can return now, but I'm not, right now I'm not looking at like specific values aside from, I'm not checking what the sum value is yet. But I think the sum in a depth first search is always going to be sum equals, well, let me, sum equals, yeah, so 3 and 9, that's going to be 1, and then that's going to be 3. And then if I'm doing a depth first search, I need to go recursively back up my call stack, right? So once I go down 1, and then I go down to 2, and then I just go back up. So it's really just looking at, I don't really need to check. Here's my big question for you. If I have this current method here, do I need a secondary method as well? Because I'm thinking with a depth first search, I don't need to do, I don't need an additional recursive function. Now, I do think
Right.
I need that with breadth first search.
Right. I think there's multiple questions here. The first one is whether you need another helper function for that recursive call, and the answer is you don't need it, but it all depends on your implementation. So you could get away with solving this problem in just one function that recursively call itself. If that's what you're doing in line 36, you just want to update that function name there. That's one. That's the first answer. The second part of the question is about CFS versus BFS here, and I like you to think about the difference a little bit more in this case because there is a clear winner between the two.
Right. I think it's like obviously depth first search, right? I mean, I think that's obviously what we're talking about. We're trying to say we're finding the minimum depth. And because, we're not talking about a huge binary tree where it's values all the way out. We're not talking about another one that keeps going ad nauseum, right? So there's not a reason to do breadth first search there.
Okay, so let me point out an example. I'm going to comment that later on. What I'm talking about here is, let's say we have a tree similar to what you're describing, but let's say the dot dot dots here refers to maybe many levels that I'm just going to skip over here, and this would be say 10. And then here I just have a number, maybe fine. Number at the end doesn't matter. So think of this dot 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 being, tens of thousands of layers there, right?
Sure.
Now this is a highly imbalanced tree, right? The left side is heavily, very long. The right side is only one. What is the answer to this tree? What is the minimum depth to this tree?
Well, it's 2.
Right, that's right. So the depth here is 2. Now, the question is, when you use DFS versus BFS, which one is more optimal? Optimal in the sense that you are able to get the answer quicker, right? So time complexity is better on average for this particular example. And so so it looks like you're saying that DFS is better, right? Is that right? Is that what you're saying? DFS.
Well, in the case where you have like something with a highly imbalanced tree like that, yeah, I would say breadth first search is better.
Okay. So just so I hear you, did you say BFS is better? BFS, which one is better here?
Breadth first search is typically better when there is lots of when your tree is like huge horizontally, right?
Okay. But this is not one of those trees, right? We're talking about highly skewed. Okay. So your answer to this question at line 22, which one is better for this example? For the example here, the one that I just drew out, which one is better? Which approach is better approach?
I think it's probably breadth first search, right? Because if you're able to look at both of them at the same time, and then you end if you're looking at 3 and 9, and then 3 and 20, and then you try to go to the next one and there's nothing, and 3 and 20, and then it's 15, and then you just keep on going down, then you've already stopped here, so you don't need to go any further.
That's correct. Yes. So you're looking at the first example, and I agree with you. In the second example, it's even more obvious that for a highly skewed tree like this,
Right.
BFS, breadth first search with a B for boy, is much better because it is able to terminate the algorithm much earlier. As soon as it identifies the level or the depth that does not have any children. In other words, as soon as it's able to find a leaf, it just stops the algorithm and says, this is the shortest path, and this is the depth, and this is the answer, right?
Gotcha.
So yeah. So now that we kind of clear up, which for this problem, the approach, which we identified the approach that's better suited, I think you can get started to kind of code that up.
Yeah. So the best thing with breadth first search is now I don't know if out of the box. Let me see something real quick because we're in a. Yeah. Okay. So let me just see if I can do. We're going to want a Q class here. Okay. Great. So, in all honesty, that's probably overkill for what we're trying to do. So let me just quickly create a new Q class, which would be this is going to be an empty array, and then we'll have 2 methods. We'll have an enqueue method, and that'll pass in an item, and that will just do value dot shift. Value dot push. Well, I could just do, yeah, that's fine. And then a DQ, which will just do a value dot shape. And then we can always, we'll probably want to be able to look at. So in terms of that, what I want to check is if my root dot value is equal to nil, and that's, I can just do return. I don't even know if I need to do return 0, honestly. And then because of that, you know, I'm probably not going to want to do a recursive solution for this. I think it'll be easier just to do it with Q. So what I would do then is this Q is going to equal Q.new, and then while, and then what I'll do is Q dot enqueue root, and then while Q dot value dot length is greater than 0. Okay, now this is a more difficult part here with the breadth first search. So if I'm pushing in the root and I'm checking the value each time, I want to go through and find the sum. Now here I can do if root dot left root dot right is not equal to nil. Q dot push. Now Q dot enqueue. Root dot value. Root dot root dot left. Root dot right. And then I need to check what the current level is. I'm getting confused a little bit here, but current level is going to be whatever because I kind of want to, I think I need to also do a loop within this while loop. But current level is going to be, so current loop is here, so, and then the while loop, I could just pretty much do a for loop, but how do I do a for loop in Ruby? Uh, to be perfectly honest, I saw a problem like this recently, either today or yesterday. So I'm refreshing my mind about it, but I did it in JavaScript. So I'm trying to think about it like how I would do it in Ruby. And in Ruby,
Yeah.
the easiest way to do it is honestly is to take, when you're doing loops, you typically want to do each loops, but doing it in, I just kind of really want, I honestly just need to do q dot length. I could actually just do a 0 dot to q dot length minus 1. Yeah. Yeah. But I also want to find whatever the current node is. And if I'm trying to find what the current node is, that's going to be, so I know I'm missing some key things here.
Yeah.
Because I want to take track of the current level. The current level, I think it is going to be an array. So I want to just push into this value. But the current node is going to be hmm. Current node. Q dot length. So I need the length, right? And the current level is just going to be, the current node is going to be whatever the Q, right? And I think the current level is going to be this, but I want to see, I need to keep whatever the level, whatever, the level size is always going to just be whatever the Q length is, right?
Okay.
So maybe I just need to do something like, And I really only care about the values here, right?
Yeah, you're right.
I'm missing something important there. So I can't just, because I'm not going to return my, well, let me see, what is this? Okay. And then I just want to return, I don't want to return the Q, and I don't want to return the Q.value, but what I do want to do, I think I need another array here, right? Let's see what happens here. Nothing happens there, because it's going to, I need like a result array, and it's going to be what? Result.length, maybe? But I need to push into this array. So maybe it's out of, oh, I'm not doing anything with that current level.
Yeah, I think you have a lot of the good pieces of this problem here. The view is great. The level is good.
Is it current level that, yeah. Okay. Okay, gotcha. So, so if I'm current node.value, right? And then if I push that, and then is that it? Oh, I also, part of it is. Missing something.
Are you trying to run the code? You need to set up a tree to
Oh,
actually call it.
well, that's also part of the problem, right?
Yeah.
So, thank you for pointing that out. So it's called tree node, yeah. And then we just what we want to do 3, 9, 20. Okay, so 3 dot left equals 9 root dot right equals 20 root dot left equals nothing root dot right equals 7 and root dot right dot left equals 6. And then so with that we need to do a puts shortest path. Put shortest path root, and that's going to equal to undefined method right. Oh, thank you. Appreciate that. Uh, 3, 9, 20. Type error. Thread Q. Oh. Oh. Level size. Q dot length. Interesting. Oh, because current level, current node dot value is undefined method valued for. Oh, interesting. What? Oh, because something like that. Undefined method value for nil class. Huh. Q dot value dot length and up to levels. Maybe it's just level size -1. Current. No, because I don't know, because that doesn't matter. Current. Maybe it is level size -1. Hmm. So that's giving me the longest length.
That's right. That's right.
So what am I doing to give me the longest length? If I'm pushing that, let's just walk through it real quick. So 3, 9, 20, 15, 7. So if I'm 3, the root value is not nil. I'm in Q, the root as 3. The length is going to be 1. And then, so 0 up to the level size minus, well, that would just be, why don't we just do, uh, yeah, I do want to continue doing zero-based indexing here. So 3 and 2. Okay, so if I DQ the current node value, which is going to just be 3, and then I push that value into the current level, so that's only going to have one value there. And then I go to the current node to the left, which is going to be 9, and I enqueue that, and then I also enqueue the 20, and then I go to the next one. So because the Q value has increased to 2, yeah, and then I go to my next value. I push in the current value, which is going to be, the last one is going to be 20. So the result length, let me just actually, gotcha. So that's not, that's not giving me the shortest path next. I mean, it's giving me each of the level length, right?
Right.
But it's not. So I don't really care about what the length. It's telling me how many levels I have. But really, all I need to know. That's going to give me each of. Oh, so I'm missing something here. I'm just. What I'm giving is I'm just giving the current. I'm just giving how many levels are there. And what this isn't telling me is how many. Well, if I have 15 and 7 and 9 and 20. So basically all I have to do is see whatever is the, I kind of want to say it's got to be whatever the modulus is, right? Because it's binary.
Modulus of what?
Perhaps this is such a small example that would be a difficult thing to do. If I have 1 and then I have 9 and 20 and I have 15 and 7,
I think I understand what you're trying to get at, right? I think you're looking at the total number of nodes and then use that number as a function of the depth. Is that right?
correct. Yes.
But I think the assumption there is the tree has to be perfectly complete for you to have some sort of formula that can
Yeah, it would have to
that can
be
get you
completely balanced, right?
right. Yeah, completely balanced. So we're not going to guarantee to have a balanced tree. But here is another way to look at this. The size of your result is three elements or uh, three arrays here, right, within the
Correct.
array.
Right.
And the three arrays correspond to three loops that you're doing within your while loop, right? You have three kind of for each loop. So if you can track the number of times you are going through the for loop, then you know that that's also the number of the maximum depth, right? Now, this problem is not looking for the maximum depth, it's looking for the minimum depth. So somewhere
Right.
along or inside that for loop, somewhere there, if you can terminate early and say, hey, I have reached my shortest depth, I can exit the program. I think that might be one way of solving this problem.
Okay. I think if I just do, right? Because if I don't have, if it is nil on either side, well, I don't want to break necessarily, but I do want to check if, yeah, so in this, if, right, so basically I just need to say, hey, um, break if and well, that's not where I want to break, but I don't know if yeah, in this loop, so I don't want to do it there because I want, but I know that this is the logic that I need. It's just like, is this like, that's not going to be helpful for me in terms of getting the result that I want. So it's not even, because I do while, maybe it's just a, no, that's going to be the same thing. Yeah.
Yeah. So I think there's definitely value in checking whether you're at a leaf or not. And line 75 is really for you to check, am I at a leaf or not, right? What happens when you are at a leaf, right? If we look at this tree here, let's say we visit 9, right? We know that, hey, 9 is a leaf. What should we do at this point?
If 9 is a leaf,
Yeah.
so are you saying if it has a parent value?
No,
Because
I'm
I
just
wouldn't
saying
know.
that at line 75, you are checking whether it's a leaf or not, right? You're checking that the
Right.
left child, right child, or not. So let's say we're at 9. We're going through this DFS. We're at 9. We see that, hey, 9 is the leaf, right? And line 75 evaluates to true. What do you want to do after that, right? Because if you don't check for that, what you'll be doing is you're going to check for 20, and then you check for 15, you check for 7, and then after all that's done, then you output 3, which is the depth of the entire tree, right? but you need to make a decision here when you're at 9. You're halfway through the tree. You're at 9. You're at a leaf right now, and you know that this is going to be the shortest depth at 9, right? Looking at the graph,
Correct.
looking at the tree here. So
Yeah.
what do you want to do when you're at 9? I think that's sort of the last thing we need to worry about for this program here.
Yeah, I mean, I just want to return the result, but I don't know if I have. I guess I could just.
Okay. Okay.
But I don't know. I don't know if that's obviously not it. Or it's actually.
Yeah.
Right.
Yeah. Yeah. So your result variable is holding all the values of the nodes of every node, right?
Correct.
And holding the values of the nodes at each level. And so that's one way of representing the depth. Another would be just a number, right? The root is at depth 1, right? And then every time you go through the for loop, that's one depth, right? So maybe you can use something else to represent the depth and then just return that.
Instead of the actual current node value? Well, result, I just need it to be a number, right?
Right.
So all I need to do is not necessarily the result. Length. Is that? So if it's 3, and then it's 2, but I need to do something here. Now it's not. I do want to return something, and I'm just trying to think if it's just, breaking out of the loop, which is something that I would want to do, but I don't want to push the current level if I'm out of the loop. If current node is left is nil and current node is right is nil, I don't think do I need to push the current node at that point? I could probably, no, because I need to queue this, and I need to figure out what the current level is. So what if I just return? Well, no, because that's going to return. Oh man. Current level dot push return. Right. Return if current node. See, what is confusing me is like only 3 is in there because I haven't cured. But that doesn't make any sense because current node should be 9. So return result dot that's just something like that. Well, right, it wouldn't be that, but it's going to be.
Yeah.
But I understand. It's going to be whatever the, and then you just I could just do this, right? And then current node dot value, and then that should be 2. Yeah.
Okay. Looks like we have something that works.
It's not. I mean, obviously, that's not what I would want to push into that result array, but I want the length of the array, and I want to increase the length of the array by 1.
Okay. I will just do one test to confirm if this is right. I'm going to add another node to the left of the left,
Okay.
and this should give us 3, right?
That would be the hope, but we'll see.
Yeah. Let's see. Let's see if I do get a 3 here. Yeah, we do. So that's good. I think it's going to work. I will have to look at it a little bit more deeper, but let me give you some feedback first, and then we can do a quick Q&A. I think you did a great job in the beginning when we discussed the trade-offs between a BFS and DFS, and you were able to explain the benefit of both of them. And we ended up choosing the right algorithm for this particular problem. It is indeed true that BFS is a better algorithm, even though the runtime would be the same in terms of order n, but we are able to terminate early if the tree is skewed. So you did a great job explaining all that, and then you proceeded to implement the correct algorithm, which is a queue-based BFS approach. I saw that as you are going through the implementation, you're able to identify the right data structures using a queue, using a variable to keep track of the level, a variable or a list of that, a while loop and for loop. All that is the right pieces to implement the BFS here. So you did all that correctly, and you're able to come up with a solution that, at first glance, it seems to be correct, right? The last thing there, you're able to identify in lines 75 to 77. That was great. To be able to return as soon as you identify a leaf node and return the level. I think there was a bit of a struggle in figuring out what the level number is as you're traversing, but that's okay. You're able to solve that at the end, all on your own. That's great. So obviously, we didn't have enough time to do additional testing. I did one test case here, but you would actually do some more. We didn't have time to go through that, and we also didn't have time to talk about the complexity. But that's something that you would need to make sure you manage time well enough to be able to go through all that within the allocated time for that question, right?
Okay.
In terms of time management, I think there's something you can improve a little bit on, just getting the answer out a little bit quicker so that you can include the testing and the complexity analysis.
Yep.
But other than that, the problem solving part is great. The coding is done well as well, except again, just the timing, maybe a little bit quicker in figuring out some of the little things to save yourself maybe 5 minutes or so. That would be sufficient to go through the rest of the requirements of this problem. And I think maybe the language itself can sometimes hinder your progress a little bit because of maybe the syntax. So something to worry about as well, that if you are interviewing for a company that requires you to run the code, definitely pick a language that is easier for you to do that. JavaScript might be easier, even for printing out debugging messages, using console logs versus sometimes the data structure might be easier as well. Depending on the problem as well, I think JavaScript may not have a stack or something, so you need to pick the right language for that. I think Ruby in general is a little hard because you have to come up with all these tree nodes, queues yourself. If the data structure is available for you, in Java or some other languages, then it will make your life much easier. But other than that, the fact that you're able to solve the problem within an hour, I think that would qualify as a pass for me in an interview.
Okay, great.
But just to watch out for the timing. You want to check in with the interviewer sometimes how much time you're given for this problem, and then make sure that you use all that time to explain every aspect of the problem, right? The testing and then the complexity analysis.
Gotcha. How important is space complexity? Like I have a pretty good understanding of like the time complexity of this, and I think that the time complexity would probably be ON. I think.
Yeah, you're right. Well, right and wrong in the sense that ON is correct. You need to also provide a reasoning why is it ON, right? You want to explain that at the worst case. The big O notation is always talking about the worst case. You want to say that worst case scenario you are visiting every node, right? And that would be
Right.
ON. And that worst case scenario could be a linked list, right? The tree could be very skewed. It could be a linked list. You have to visit until the end of that list in order for you to know the depth, which is order n, right?
Gotcha.
And then you never say I think or I guess or whatever. You don't want to show the interviewer that you are not confident about your answer. I would rather think that you can be wrong, but never try to show that you're guessing something. Because if you guess something, even if you got it right, they're not gonna treat it as correct, right? They're gonna say that you just guessed it because you're remembering that a BFS is order n operation.
Yeah, right.
So never say something that you're not confident with, and always use your code to help you derive the answer, right? If you're visiting each node just once, then it's a linear time solution, right? Space-wise, because you're using a queue, at the worst, you are storing everything again, so it would be also linear space. So that's what you would do. You would give the answer and maybe a quick one-liner to explain why that is the case. That would be a perfect solution, yeah, for an interview.
Okay. Great. And then, yeah, the basically, okay. So just review time complexity. Yeah, I guess my question is space complexity like really, is that something that I really have to have it?
Yes, yes, you do. And also, the most important thing is get the space complexity correct based on your algorithm and not necessarily the optimal answer. Sometimes some questions may not be easy to implement the optimal solution, so it's okay to implement a suboptimal solution. But what is required is when you implement your solution, your space-time complexity has to be correct based on your solution. So you need to be able to argue that you're using, either linear space or more. And generally speaking, for space, if it's not linear, it's constant, right? It's rare that space is more than that. Rare. I'm not saying that it doesn't happen, but most likely it's linear or constant. When people say it's logarithmic, it's usually in binary trees where the depth of the tree is log n. But even that is worst case scenario still linear if the tree is skewed. So it's really just a choice of two, and you just have to look at your code to see if you're declaring any list or any data structure. Anytime you're using a data structure, it's very likely it's a linear space solution.
Okay, great.
All right then. Thank you for using interviewing.io today, and I hope you have a great rest of the weekend.
Yeah, thank you. Thank you for all your help on this. This was great practice. Thank you so much.